So what we're going to cover today is circles. Shouldn't take too long. And then tomorrow we're going to kind of extend that understanding into ellipsis. Okay, I think that's tomorrow. So the circle, the hardest part of it again will just be kind of completing the square. Everything else will just be understanding what the formula represents, what the different variables are, and how to find that information or use that information depending on what's given. So this is going into the broader unit that we call conic sections. And the reason they're called conic sections is because if we take an infinite cone such as this and we slice it different ways with a plane, depending on how that slice goes through, it forms one of these four features. It either forms a circle if we slice the cone perpendicular, parallel. If we slant it a little bit, we get an ellipse. If we kind of go through the edge and it extends beyond, that's where we get our parabola. So we're elongating the ellipse so far that it never comes back around. And if we go perfectly vertical, we get what's called a hyperbola, which is just two parabolas kind of facing out from each other. Okay, and they're going to be symmetrical on an axis. And so these are our four conic sections. We've been using parabolas for a long time. Now we're going to move into circles, ellipses, and then hyperbolas at the end of the week. So a circle geometrically is defined as the set of all points on a plane that is the same distance from a fixed point. That fixed point being the center, and that distance being the radius. Okay? So those are kind of the two important features of the circle that we need to know. Is just where is its center and what is its radius, and that's going to be able to give us that information that we need. It boils down to very informally the distance formula. That's how we can find the equation for a circle, is just using the distance formula, which if you may have seen before, the distance formula comes from the Pythagorean theorem. Okay, that's all it breaks down to, is that if we take a line and we draw it from the center to the edge of a circle to form the radius, and then we draw a vertical line and a horizontal line connecting it back to the center, we get a triangle. Okay, and so that radius is found by using the Pythagorean theorem, a squared plus b squared equals c squared. C being that distance or that radius. Well, the only difference between the Pythagorean theorem and this formula is instead of having everything squared, well, it's just a matter of square rooting both sides so that the distance is already isolated. There's no extra process there. So we have the square root of a squared plus b squared. Okay, well, where do we get x2 and x1 for a and then y2 and y1 for b? Well, that comes from just finding distance, linear distance. The distance from here to here is going to be the x values, okay, the difference in those x values, x2 minus x1. That gives us side length a. And then that vertical line will just be the distance or the difference, different color, of the y values. So y2 and y1. And we're just finding that distance there by subtracting those values to get b. So the distance formula is just a reworking of the Pythagorean theorem. Okay? And so that's what we're going to be using when we look at that, is just the Pythagorean theorem. So we want to look at kind of the x and y values of our points in order to get our line. Okay? So we want to find the what those x and y values are, and this point right here isn't kind of on any easy to determine place, but what we have been given is one of the points, and we've already been given the radius, and that's all we really need to do in order to find the center or the equation for the circle. And so 0, 0 is going to be our first point. That's going to be x1 and y1. x1 and y1. And the radius, that is our distance. The radius of 4 is our distance. And so we can take our distance formula and just plug it in and say, okay, well, I don't know what x2 is, so I'm just going to leave it as x. But I know I'm going to subtract 0 from it. And then I've got y2. Well, I don't know what y2 is. I don't know what that second point is, but I do know what y is, so I'm just going to subtract that. and then I know that my distance is 4. Okay, that's my radius. And then we can just kind of simplify that a little bit. If I take x and subtract 0, does that change anything? No, so I don't need it. Same thing with the y. I have y squared, okay, equals 4. And just for clarity's sake, I don't really like having the square root. So what can I do to get rid of that square root? Yeah, square both sides. So if we square both sides of the equation, we end up with x squared plus y squared equals 16. And that is the equation for the circle. And we'll see a standard form for it in a minute, but I want you to kind of recognize where that form of the equation comes from. Now the idea is going to be the same even if we're not at the center. Okay, we can move our circle all over wherever we want it, have different radii. And so here we have a circle in a new location, radius of 4 again, but we have this new spot. And so what we can do is still take that distance formula, the difference in the x's squared plus the difference in the y's squared. The square root will equal our distance. That's our distance formula. Okay? Pythagorean theorem. So again, we're leaving x2 and y2 alone. I don't know most of these points. I don't know what they are. I can find some of these other ones, but it doesn't really help me. I want to leave a variable in there. So we're going to leave x and y, but now we have something other than 0. Okay? So given the center 3, -2, what's the x value for the center? 3. So we're going to plug in x minus 3. What's the y value for the center? -2. So y minus -2, and then our distance was 4. Same idea. Don't forget our square. I want to clean up the equation a little bit. X minus 3 just stays x minus 3. Y minus -2 becomes y plus 2. And then since I don't want the square root anymore, we square both sides and we end up with 16. So we can square both sides, clean up what's in the parentheses, and then we have our standard form, which tells us where our circle is and what the square of the radius is. And so this goes right into the formal definition for the standard form of a circle. So the standard form, or the center radius form, is x minus h squared plus y minus k squared equals r squared. You'll see there's some similarity to our parabola equations. We have these chunks of parentheses with h and k. Instead of telling us where our vertex is, now it's referring to the center. Okay? So h and k are still kind of that key feature, but on a circle it's the center, on a parabola it's the vertex. Note there's still going to be a sign switch because it's minus h minus k. And then notice that our constant is going to be the square of the radius. So if we ever need the radius, we'll have to square root that number. The constant is going to be the square of the radius. And so if we're given this information, instead of going through the vertex or the distance formula, we can just plug it straight into our standard form. Okay? As long as we have our standard form equation, we can just identify what is h, what is k, what is r, plug them in, and simplify. So we want the equation of a circle with a center at 2, -1, and a radius of 3. What is h? 2. What is k? What is r? And it's as simple as just plug and chug. X minus h was 2. Y minus -1 is plus 1. And then we have 3 squared to get 9. And that's it. That's all you need to do to write your equations for your circles. You need to know your center. You need to know your radius. Drop it into your formula. Clean it up if you need to. All right, so that's the easy part. Questions, comments, concerns? I say the hard part's coming next, but again, the hard part is including the square. All right? So we want to find the center and the radius of the circle. Problem is, this isn't in standard form. It's in general form. It's all expanded out. There's no parentheses. We've got x squared and x. We've got y squared and y. Okay, so it's not in standard form. We have to get it in standard form. Just like with the general form of parabolas, in order to do that, we have to complete the square. The only difference is that because we have x squared and y squared, we have to complete the square twice at the same time. And that's what this is going to look like. We're going to group the x's and the y's together in their own setting, and we're going to go ahead and move the constant to the other side. So we're going to complete the square with this, and we're going to complete the square with this. So we'll start with x squared plus 6x plus something. And then over here, we're going to have 51 plus that same thing. And then when we move on to the y squared minus 4y plus something, on the right side, we're going to be adding that again. So we're going to be adding two numbers to the left side and two numbers to the right side. Those two numbers will be based on whatever we need to do to complete the square for both of those variables. All right, so how do I figure out what goes in my red box? And then what? And then squared. B over 2 squared. 6 divided by 2 squared. So we get 3 squared. So 9 and 9. All right, what about the purple box? 4 over 2 squared. 2 squared. So then we get, if I wrote the correct number, 4. So now we've completed the square for both the x's and the y's. And then we're adding those same values to the right side. So x squared plus 6x plus 9, what will that factor to be? X plus 3, quantity squared. And then the y will factor to be y minus 2, quantity squared. And then on the right side, we'll go ahead and add all those up. 51 plus 9 plus 4. Now we're in standard form. So completing the square is the process that can take all of our conic sections from general form to standard form. Every single one. Okay? We'll be doing completing the square to get from general form to standard form. And then from here we can compare it to our formula. So x minus h squared plus y minus k squared equals r squared. So my center is h and k. What does h equal? Negative 3. What does k equal? 2. We have negative 3, 2 for our center. And then what's our radius going to be? 8. 64 is the square of our radius, so we square root that to get 8. And there's our process for identifying those values. Questions so far? All right. Now, we don't have any constants to move on this one, so we don't have to worry about that step. What else do we need to do? What should the order be?
Move the negative 8x twice.
Okay. So we'll have something there. And something there. And then we have 0 plus something, plus something. So rearrange it, group your X's, group your Y's, add your boxes, make sure you put 2 on the right side, make sure your constant is on the right if you have one. What's going to go in our dark blue box? Good. Okay, 8 over 2 squared. What goes in our light blue box? 9. All right. First part, factors to be. Good. And our second part, factors to be. 20 squared, good. And our right side simplifies to. Good. What is H? Good. What's K? 4, -3. And what's R? 5. See? Not that bad, right? I think circles are fine. I like circles. Why don't you go ahead and start on that last one on your own. Give that one a shot. Bless you. How we do? Okay. Alright. This will pause for today. You can start on your math lab assignment, and then tomorrow we'll pick up with. In just a minute, yes. I'll let it finish.